Good morning. My name is Jun Inoue from National Institute of Polar Research and JAMSTEC. By the way, I love the Mount Fuji, the highest mountain in Japan. And 2 days ago, the Japanese newspaper said the Mount Fuji will become a World Heritage. So we are very happy to hear that. And this picture shows the very famous wood print, the Great Wave by Hokusai. So the interaction between the high waves and the highest mountain in Japan is very beautiful, especially the perspective of and symmetry of highest mountains and higher waves than the highest mountain is very beautiful. And yes, I'd like to mention that I think these fishermen really needed the observing network to predict these high waves and the strong winds. During my talk, I mentioned this picture again, so please remember this picture. So first of all, this is my mind map related to the Arctic research. And of course, this is a Japanese version. You cannot understand in detail, but you can also imagine how I'm thinking the Arctic research and the surrounding world. So the topic is the Arctic, of course. And red branches shows a kind of science and some processes or phenomena. So something, for example, sea ice retreat, ice thickness, snow cover, river discharge, ocean acidification, teleconnection, AO, NAO, blocking, something like that. These are scientific motivation. And to understand these phenomena and the processes, we need an observation instrument and modeling system. So green branches are such kind of tools for the research. For example, there are some buoys, so ice desert profiler, ITPs, ice mass balance buoys, and ships, research vessels and icebreakers, or aircrafts, among UAVs and satellites, regional model, GCM, wave analysis, something like that. These are all tools. And to conduct such a big project, field experiment, we of course need international collaboration. So for Japanese, US, NOAA and the University of Washington, very important partner, or some international framework, Arctic Council, and WMO, PAG, also very important for us. And to conduct the research and analysis, we also need manpower, especially young scientists, early career scientists. So research institutes and universities are very responsible for the education, I think. And the last branch is a kind of social thing, public communication. This area covers a very wide area. For example, mass media, TV program, newspapers, and internet, and more politically national resources, and northern shipping, northern sea route. And most of people are interested in the weather forecast and the seasonal forecast, and human issues related to the diseases or health. So in my talk, we we'd like to consider a link between the science and the public communication. So one of the hot topics among the researchers as well as the ordinary people, severe winter, recent severe winter at mid-latitudes. So there are some papers from last year, and we also published in journal Climate. And yeah, in this paper, the sea ice reduction over the Barents Sea are very important to make anomalous dipole pattern, warm Arctic and cold Eurasian anomaly. And this means that we are facing a reality resulting from the Arctic climate change. Even in Japan, recently we have experienced very cold winters since 2005. This is the 2006 January. So there are lots of snowfall over there. And cold air temperature and snowfall are very influential for the traffic, economy, and health. So by concerning the health, there is a unique investigation in Japan. So bottom line is the people are physically sensitive for cold climate living in the mid-latitude. Left panel shows the monthly distribution of rate of death in Japan. And you can see that winter from December to March, there is a high rate of death. That means winter is a very risky season in Japan, as well as the other mid-latitudes countries. And the right panel shows the daily rate of death as a function of daily maximum air temperature. And there is 4 places from northern Japan to southern Japan. And by looking at the lower temperature below 8 degrees Celsius, this is almost winter time. You can see that the rate is highest in the southern Japan, while in the northern Japan, Hokkaido, I was born there, the rate is lowest. So that means people living in Hokkaido is very strong for the coldness. In other words, people living under warmer climate, higher rate of death against cold events. So if we can predict the cold event or cold winters in advance, we can prepare or decrease such kind of rate of death. And the sea ice retreat also, of course, hot topic over the northern sea route. So as sea ice retreats, the open ocean, ice-free ocean getting open, and northern sea route possibly available. Ships can pass along the Arctic coast very frequently. But we also know, at least I know, that the marginalized zone, there is a very strong temperature gradient that is a very favorable for the cyclogenesis. So lots of Arctic cyclones produces the strong winds and high waves. So remember the great waves picture. So that is a very dangerous situation in the Arctic Ocean, especially icing on a ship and ice drifts are very dangerous and disturbing the ship navigation. So we don't know if Northern Sea route is available or not. Or we have to assess such kind of thing from the observational work. In fact, 2010, we have succeeded in observing the Arctic cyclogenesis near the marginal ice zone over the Chukchi Sea. So if we have lots of observation over the Arctic Ocean, actually we did the radio zones observation a lot. It will be possible to improve the numerical prediction and contributing to the ship navigation more safely. So what we can do now is to improve the numerical prediction, especially predictability of NWPs. Not only by the improving the model itself, but also we can expand the Arctic observing network. For example, we can launch lots of radio zones from the ships and land stations, or we also deploy lots of surface drifting buoys over the ice and the ice-free ocean. And we also have a data assimilation system. And it's possible to evaluate the effect of such intensive observation and hopefully propose the future observing network. So as a first step, we will start to establish the small radio zones network coming summer, 2013, September. And at least our ship, Japanese research vessel at the higher Arctic, and the Nielsen and the Tix land station will provide additional radio zones data during this period for the weather forecast and the data assimilation research. This is my example for the observing network design and implementation, but you also have your own idea. So to design and implement the observing network, we have to consider at least these 5 items. So scientifically, in my case, Arctic cyclones and sea ice retreat or air-sea interaction are very important under scientific motivation. And we have tools, radio zones, research vessels, drifting buoys, stations, assimilation system, aircrafts. Of course, we need a international framework, IAS, CLIC, and other institutions. And more important is students can join this kind of cruise and analysis or project. And we also considering the link between scientists and mass media, or improving the weather forecast and more safe Northern Sea route, or disease and health issues. And I don't know the answer. Who needs the observing network? Not polar bear, but not only scientists, but stakeholders and politicians or companies should be interested in the Arctic. So to consider the Arctic observing network, all these items, 5 items, are closely linked. So after this session, we may discuss in detail. Thank you for attention.